are going to complete the square. And, oh man. Okay, there we go. Now we're back. So today we are completing a square, and the directions for completing the square are down here at the bottom of the page. Now, completing a square was always this weird procedure for me when we were in school. Well, you just learn procedures. That's all you learn. And no one ever really explained why it was called complete the square, okay? And so what we start with is something like that. Do you know what that is? This represents an X. Well, so once upon a time, back in elementary school, these rods and plates and little cubes, they represented 1 and 10 and then 100, right? So now that we're in algebra land, this is now represents an X. Okay, so this is 1x, and if I have 2 of them, that would be 2 x's, okay? And this is still a 2, 1, 2, so those are still units. These are x's, and then if you take the x and multiply x times x, what do you get? X squared. And so this plate now represents x squared, which when you think about it, when this used to be a 10 and a 10, what is 10 times 10? 100, all right? So it was 10 squared. So now this is x times x, and it's x squared. Okay, so and so let's say I have a polynomial that is x squared plus, let's see, I'm doing this off the cuff here, 1, 2, 3, 4, 5, 6 x's. So this is what I have. I have a polynomial, and it is x squared plus 1, 2, 3, 4, 5, 6 x's. And what I want to do is I want to rearrange it to literally, physically complete the square. And that's what the process we're doing is. Okay, so I have an x squared. And what I want to do is sort of split these apart so I can create a square. And so I'm going to take half of these and rearrange them so they fall on the bottom here. So again, I'm trying to complete a square, literal square, well, physical square, really. And so here I have this square shape, and then the question is, what do I need to complete the square? What fits in this missing bit here? 9 little things, yeah? 9 little units? Does that make sense to you? Now, how did we get the 9? 3 times 3, yeah. And the 3 came from splitting, yeah? Splitting the 6 x's up. Okay, so when we take our x's, we have to split them into 2 little sections, 2 little groups. And then if you square that, you get the 9 little units, yeah? So we did this in algebra or in geometry last year too. So we have to fill in with the 9. This is why it's called completing the square, because you're quite literally completing the square. I keep saying literally, but it's really physically completing the square. Because we actually do it. So we would have to add 9 to complete the square. And so you can imagine, what if I had x squared plus, how many x's here? 8 x's. So how would we complete the square? You'd take 4 x's, and we'd rearrange. And so then what would go in the square? 16, which is 4 squared. Okay, so we're taking our x's, splitting them in half, or splitting them into 2 groups rather, and then squaring that. And that is what we have to add in to complete the square. Okay, so that is why it's called completing the square. And when I learned that, I was like, oh my God, everything makes sense now. Like, it was like literally life-changing for me. When I learned that in my 3rd year of teaching, I think, is when I finally learned that. So it was pretty cool. Now, for us, completing the square gets a little bit complicated. It is a square root method, essentially, but it's a little more complex. And so we might have a number in front of x. We would want to divide that off. We need the x to be a solo x squared, okay? So we need that x squared to have a 1 in front. So we end up dividing both sides by a, so if there's a number in front, so that we get x squared plus something x. And from there, we're going to complete the square, which I'll just show you how to do because it's better to just understand what's happening. So here we go. So number 9 is solve by completing the square. Write all answers in simplest form. Again, we could get real answers. We could get irrational answers. We could get imaginary answers. And so that's what we want to pay attention to here. But we are solving. So my quadratic here has a 1 in front of the y squared, so that's fine. The first thing we want to do is move the constant away. He's not helpful to me right now, although there are multiple ways to do this process, but this is, I think, the easiest. Y squared plus 12y, leave a little bit of space, equals negative 20. So I'm moving the constant to the opposite side, and we're going to leave a little space because I need to add in the value that completes the square. Now, if I add a value on the left side of the equals, to keep my equation balanced, I must also add it on the right. Okay, I have to add that value that completes the square to both sides. So how do we get the value? Here's how many y's we have. What do we have to do with it? We have to split them into 2 groups. So how many are there? 6. And then we have to square it, and that's what we're going to add to both sides. 12 divided by 2 squared, and that's what goes in these blank spaces, okay, every single time. Split those apart and square them. Now, I wrote 6 squared. I'm going to go ahead and change that to a 36. Again, you probably write it over here just so you know where that came from. Now, what we've created is a perfect square trinomial. We created the number that makes this perfectly factorable, okay? So we have a trinomial that we can now double bubble. All right, let's see. Y times y is y squared. What times what is positive 36? 6 times 6, right? So a positive 6 and a positive 6. Hey, that's cool. All right, over here on the right-hand side, negative 20 plus 36? 16, okay? I need to turn the page here. Make sure I'm not going to make a mistake of myself here. All right, so we get 16. Now, you'll notice, hey, those factors are identical, right? Okay, so the easy thing to do is to say, hey, let's just write it as the quantity squared. Because that's cool. Now that it's something squared, now I can square root that thing. So if I take a square root of both sides, what do I need to remember when I take a square root? Plus or minus every single time. So we're going to take the plus or minus both sides there. The square root and the square cancel each other out, and they leave behind y plus 6 equals plus or minus 4. The square root of 16 is 4. And then how do you get y by itself? Subtract the 6. I'm going to write it as subtract 6 plus or minus 4. Now that has to equal something. It's negative 6 plus 4, negative 2. And negative 6 minus 4 is negative 10. There we go. So you do have to be a little bit careful, but that's the process. And it goes pretty quick. I show every single step when I do this process because it makes sense when you double bubble and then collapse it, condense it down, and then go from there. It makes perfect sense. Now, do you have to show all of those steps? Absolutely not. I would say this is an absolute step there. Here's the other absolute step. And then you can probably get to your answer maybe. But there's definitely a couple of steps you can skip if you want to, okay? I'm going to show all of them. Number 10, what should we do first? We will. I'm going to wait just one more step. What am I going to do before that? Yeah, I'm going to move that 25 first. So then 7b squared plus 14b equals 21? Yeah. All right, now what did you say there, Brody? Yeah, so let's go ahead and divide by 7. We cannot, it's such a messy process to complete the square with a number in front. So we're going to go ahead and divide every single term by 7 just so we get a leading 1. So we have b squared plus 2b, leave some space, equals 3. Leave a little bit of space because we have to complete the square. All right, what's going to go in the little blank space on both sides? No. 1 squared. Take that b value, whatever's in front there, 2. Divide it by 2, and then square the result. So 2 divided by 2 is 1. Squared is still just a 1. All right. All right. From there, we can double bubble. How does that double bubble? B plus 1 and b plus 1. It's so easy. And then I'm going to condense that so it becomes b plus 1 quantity squared is equal to 4. And then square root both sides. Don't forget. Plus or minus. Very good. All right. So we're left with b plus 1 equals plus or minus 2. And then I'm going to subtract the 1. All right, so I have negative 1 plus 2, which is 1, and negative 1 minus 2, which is negative 3. All right. Do you need a writing implement there, Will? No, okay. Okay. All right. How is completing a square? It's pretty easy, right? It's pretty easy. Okay. We're going to do these last two just because of the numbers we get. All right. So number 11, what should we do first? Minus 8. So I get v squared minus 13v, leave a gap. And then when I subtract the 8, I'm going to get a negative 12. Leave a space. Now, it gets tricky now. What do we have to do with this number in front of the v? Divide it by 2. So negative 13 over 2. And then we have to square it. What do you get when you square that? 42.25. Barf. Math frac that.
169 over 4.
Yeah, 13 times 13 is 169 over 2 squared, which is 4. So we're going to add 169 over 4 to both sides. Believe it or not, fractions are your friend here. They will work out pretty nicely. All right, from here we get to double bubble. V times V is V squared. What times what is 169 over 4? 13 halves. And we need to be negative. Negative 13 halves and negative 13 halves. It's right here. When you write out that C value, that is what goes in your bubble. All right? It works great. Okay. Over here on the right-hand side, I'm going to get a common denominator. So this is 12 over 1. If I multiply by 4, that gives me negative 48 fourths plus 169 fourths. And I am doing this on purpose. We need to be able to work with fractions because when we get to trig, it's all fractions, okay? So we need to practice those fractions. So I multiply top and bottom by 4 to get negative 48 fourths, which is the same as negative 12. I can condense. I get v minus 13 halves quantity squared equals 169 fourths minus 48 fourths is 121/4. And then what do we need to do? Square root. Don't forget. Plus or minus. Very good. So we get v minus 13/2 equals plus or minus. What's the square root of 121/4? 11 twos. 11/2. And then we're gonna just add the 13/2. 13/2 plus or minus 11/2. What does that turn into? 13/2 plus 11/2 is 24/2, which is 12. 13/2 minus 11/2 is 2/2, which is 1. All right? Fractions are your friend. They are not the enemy. Get used to them. All right. Number 12 here. Last one for today. What should we do first? Move the 44. 4a squared minus 20a, subtracting 44, that's going to give me negative 49. Then what should we do? Divide by 4. So I'm going to divide everything by 4. So I get a squared minus 5a, leave a space, minus 49/4. And now, what goes in the space? As a fraction, negative 5/2, and square it, 25/4, 25/4. In both spots there. Okay. Now, double bubble. Yeah, it is positive or negative 5/2. It's negative. It is exactly what's in the parentheses here, every single time. So I can write a minus 5/2, quantity squared, or I could double bubble, but I think you got the picture there. And then negative 49/4 plus 25/4 is negative 24/4. Then we need to square root. Don't forget, plus or minus. What's this answer going to be?
Can't you simplify that negative 24?
Oh, so I could simplify the 24 and the 4, but I would, it would be 6. You're right, that does simplify. Sorry, I was thinking about taking a square root ahead of time. So, yes, 24/4 is the same as 6, so negative 6. Thank you. Good plan there. Yes, it was negative 24/4, which then became that negative 6. All right, cool. Very good idea. All right, so this answer is going to be real or imaginary? Imaginary. We got a negative under the radical. All right, so when I take a square root, I'm left with a minus 5/2 equals plus or minus I square root 6. I radical 6. The square root negative 1 gets to come out as an I. It stays right next to that radical. And then this 5/2, I just have to move it over. So I get a equals positive 5/2 plus or minus I root 6. And this is a beautiful answer. It's perfectly simplified, just like that. Okay? Questions for me? All right, super duper. All right, that's it. That's all I got. How long was that? 19 minutes. Okay. All right. You have